Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 33rd module titled Factor Analysis under the paper Tourism and Hospitality Research. Dear friends, after the completion of this module, you will be able to understand the meaning and the scope of factor analysis. You will be able to understand how factor analysis works. You will also be able to understand how to interpret the results under factor analysis. First of all, friends, I would like to give you a brief introduction about the topic. Research has been classified as science as well as an art. This means that research follows a predefined process in order to make research by one fellow comparable by another. It also means that research is a discipline in which a researcher becomes more apt to practice. Once the data has been collected, the next phase in research process is the data analysis. Data analysis is the process by which sense is made out of the data gathered. The process of data analysis consists of multiple phases. The data analysis techniques are divided into three broad categories. That is, the univariate analysis, the bivariate analysis, and the multivariate analysis. Bivariate analysis is an analysis when there are two variables involved in the study. Common techniques used in this analysis are correlation, bivariate regression, t-test, ANOVA, etc. Multivariate analysis is an analysis where more than two variables are involved in the study. The common techniques used for this analysis are multivariate regression, discriminant analysis, logistic regression, ANOVA, factor analysis, cluster analysis, etc. The current lesson discusses one of these techniques of multivariate analysis, that is the factor analysis. Now here we start with the factor analysis. Factor analysis is the name given to a class of procedures and algorithms which are used for data reduction. Data reduction refers to the philosophy of decreasing the number of dimensions or the variables across which analysis is to be undertaken. What does the dimension reduction mean? In order to explain the dimension reduction, it is important for the readers to understand the difference between the concept, construct, and a variable. This difference will highlight what is being measured and how. First of all, the concept. It refers to an abstraction formed by the literary community. They are rich in meaning but cannot be measured directly. Second is the construct. This word in research refers to the process of narrowing down the operational definition for the concept. Concepts usually have multiple dimensions and hence multiple definitions. In research, it is very important for a researcher to narrow down one or a couple of definitions which would be used for research. Therefore, operational definitions describe the operations to be carried out in order for constructs to be measured. The third, variable. The third word, which is very important in research, is referred to as variable. Once a researcher has decided the concept that they want to study and the construct of operationalizing that concept, the next stage in the research is determining the dimensions of the construct being measured. For example, a researcher wants to study satisfaction from various services in a 5-star hotel. The concepts that the researcher wants to study in this particular research are customer satisfaction and service quality. Technically, multiple definitions can be found of service quality. However, when the researcher decides to define service quality in terms of reliability, assurance, tangibility, empathy, and responsiveness, then these 5 become the variables of the study and the serve call becomes the construct of the study. In research, once the variables have been decided, the next stage is to finalize the process of measuring them. Usually, each of the variables has multiple dimensions which needs to be measured, and therefore the researchers are required to ask multiple questions for each one of the variables and its dimensions. Therefore, in the above example, service quality would have 5 dimensions, and each one of these dimensions would have 3 to 4 questions. For example, assurance would have 4 or 5 questions, and therefore serve call in total is a 22 item scale for measuring service quality. Important thing to understand here is that if the researcher were to analyze service quality directly in terms of 22 questions, which framed the questionnaire actually, the analysis would have been a little complex. Therefore, by clustering these 22 questions into groups which measured the same thing, serve call was converted into 5 dimensions, that is reliability, assurance, tangibility, empathy, and the responsiveness. This technique of reducing the dimensions of analysis is referred to as the factor analysis, that is the reducing dimensions from 22 to 5. It is important to note that factor analysis is a technique which is used for dimension reduction, that is clustering the items into variables. The process of converting respondents into homogeneous groups is referred to as cluster analysis. In research, the problems are complex and include large number of variables which might be correlated. Thus, this correlation between the variables which leads to them being reduced to a manageable level. These underlying relationships are presented in terms of factors. Therefore, factor analysis is a method which is used to identify structures, factors, dimensions that underlay the relations of the observed variables. In factor analysis, this relationship is used to convert observed variables into latent variables. Now, the uses of the factor analysis. Factor analysis as a technique is used for following purposes. First, explore data for patterns. As discussed before, data analysis techniques are divided into 2 categories, that is, the exploratory data analysis and the testing of hypothesis. Many a times in the initial stages of data analysis, the researcher is not aware of the nature of the data or the items or the variables. In such cases, factor analysis is done as an exploratory tool to understand the nature of variables and underlying relationship amongst them. The second use is data reduction. Factor analysis as a technique can also be used to reduce the large number of questions, items, or variables into a more smaller and manageable number of variables. The variables thus obtained are referred to as factors and formulate the latent variables for the study. The third use, confirm hypothesis of factor structure. Many a times, the starting point of the research is someone else's research. This previous research usually hypothesizes a structure for the variables which is referred to as factor structure. Factor analysis can be used to test this factor structure as well. Now, the types of factor analysis. There are broadly two common types of factor analysis: the exploratory factor analysis and the confirmatory factor analysis. The exploratory factor analysis is the summarizing data by grouping the correlated variables. It is the investigating sets of measured variables related to theoretical constructs. It is usually done near the onset of research. The type of factor analysis and the PCA we are talking about in this chapter only. The confirmatory factor analysis. It is more advanced technique. It is done when factor structure is known or at least theorized. It is done for testing generalization of factor structure to the new data, etc. And this is tested through SEM methods. The current module focuses only on exploratory factor analysis. Now, let's take on the assumptions of factor analysis. Factor analysis is a part of general linear model family. Therefore, factor analysis and its related procedures are based on same set of assumptions as that of multiple regression. First, no outliers. One of the basic assumptions of factor analysis is that the dataset does not have any outliers. Secondly, adequate sample size. Factor analysis as a tool is very sensitive to the sample size. It is very important that sample size should be adequate before the factor analysis can be undertaken. The most common rule of thumb in this case is that the sample size should be 10 times the number of variables being measured. The linear relationships. The third assumption of factor analysis is that the variables should have a linear relationship. Factor analysis as a tool is a study of correlation between the variables. Therefore, if there is no linear relationship, factor analysis cannot work. Another assumption is regarding the interval data. Another important assumption for factor analysis is that the data must be collected at least on interval scale. The factor analysis cannot be applied on nominal or an ordinal scale. Lack of high multicollinearity. It is important that in factor analysis, the data set does not exhibit the multicollinearity. Multicollinearity refers to the tendency of a variable to be significantly correlated with multiple variables under study. Next, the normality for purposes of significance testing. As discussed above, factor analysis is one of the parametric techniques of analysis. Therefore, the assumption of normality is important for factor analysis. The factor analysis model. Mathematically, factor analysis is very similar to multiple regression analysis. In this case, each variable is expressed in terms of the linear combination of the underlying factor. The amount of variance shared is referred to as communality. The factor model is represented as the xi, which is equal to ai1f1 plus ai2f2 plus ai3f3 plus till ajm plus fm plus vi and ui, where xi stands for ith standardized variable, aij is the standardized multiple regression coefficient of variable I on common factor j, f stands for common factor, the vi stands for standardized regression coefficient of variable I on unique factor j, ui the unique factor for variable I, m is the number of common factors. Now we come on to the process of conducting factor analysis. The process of conducting factor analysis is a 6-stage process. First, the problem formulation. It is very important to understand that averaging out the observed variables in order to get to latent variables leads to loss of sensitivity in the data collected. Therefore, it is very important to be clear about the reasons for which the factor analysis is being conducted. Step number 2. Construction of correlation matrix. The factor analysis has the assumptions which are very important. These are linear relationships and lack of multicollinearity. In order to test these two assumptions, it is important to make a correlation matrix for the data being analyzed for factor analysis. For factor analysis to be appropriate, the variables must be correlated. Usually, it is said that correlation matrix is made to test the hypothesis of identity matrix. Ideally, a researcher wants to reject this hypothesis. Third, the method of factor analysis. Method of factor analysis refers to choice of method which is used to derive weights and factor scores. There are three methods of factor analysis: maximum likelihood, the principal axis factoring, and the principal component analysis. Maximum likelihood is the most commonly used method and is also used by default as a method in most of the softwares. Step number 4. The number of factors. It is possible for a researcher to extract a given number of factors from the data set. Several procedures have been suggested to determine the number of factors which should be extracted. For example, on the basis of review of literature and on the basis of eigenvalues, where the eigenvalue is greater than 1 are retained. And on the basis of scree plot, usually here in this case the point at which an elbow is formed determines the number of factors to be extracted on the basis of percentage of variance explained. Higher the percentage, better it is. The fifth, rotation method. One of the most important outputs in factor analysis is the factor that can matrix. This particular table indicates as to the observed variables which correlate with the latent factor variable. The initial solution is an unrotated one. In rotating the factors, an attempt is made to improve the efficiency of the factor pattern matrix by obtaining the solution where each one of the factor has non-zero or significant loadings or coefficients for only some of the variables. There are three methods of rotation. Orthogonal rotation, here right angles are maintained during rotation between the axes. Secondly, the Varimax procedure and the oblique rotation. Varimax is the most common method of rotation. The sixth and the last step, interpret results. The last step in data analysis is to interpret the factor pattern matrix. It is important to note here that it is the rotated factor pattern matrix which is interpreted. Now, the factor analysis under the SPSS software. In order to understand factor analysis, we continue again with the example that was used in the previous lessons of ANOVA, cluster analysis and discriminant analysis. In the year 2001, Goa's share of total foreign tourists coming to India was 4.78% of the total foreign tourists arriving in India as per the report in 2002. This share of Goa of total foreign tourists coming to India decreased to 2.47% of total foreign tourist arrival in the year 2014. The incumbents of the industry hire a researcher to study the factors affecting the customer satisfaction. In order to help the researcher and to understand the nature of the data, factor analysis was applied on the 13 variables selected for the parameter of customer satisfaction. Now, let's take on the step-by-step approach of conducting factor analysis in SPSS. Step 1. Select, analyze, dimension reduction and the factor analysis. Step 2. Move all the 13 variables to the other side. It is important to understand that factor analysis is done on dependent and independent variables separately. doing single factor analysis could result in cross-loading across dependent and independent variables. Step 3. In descriptives, ask for KMO and Bartlett's test of sphericity. The Kaiser-Meyer-Olkin, or generally used as the KMO measure of sampling adequacy, is an index used to examine the appropriateness of factor analysis. Any high values, that is between 0.5 to 1, indicate that factor analysis is appropriate. The Bartlett's test of sphericity compares your correlation matrix to an identity matrix. Therefore, we want KMO value to be high. However, Bartlett's test, we want the null hypothesis to be rejected. The null hypothesis states that there is identity matrix, where if P is less than 0.05, accept alternate hypothesis, or vice versa. Then next, click on extraction and then select the scree plot. The next step, in rotation, select the Varimax, press continue and OK. The first table in the output sheet that you can see is the KMO and Bartlett's test. The KMO measure of sampling adequacy is an index, as already told, used to examine the appropriateness of factor analysis. Any high values between 0.5 to 1 indicate factor analysis is appropriate to be used. Again, the Bartlett's test of sphericity compares your correlation matrix to an identity matrix. In this case, the sample size is adequate for factor analysis and there is no identity matrix, and therefore the correlation is significantly different from 1 and 0. The seventh step. The next table in the output sheet is the commonality table. This table explains the amount of variance a variable shares with all the other variables. Here, about 58.8% variance is explained by the first variable only, that is the true HOL. Ideally, variables with less than 0.5 commonality can be removed and calculations are done again. In this particular case, none of the variables has commonality less than 0.5 and therefore there is no need to delete any of the variables. Step 8. The next table in the SPSS output sheet is the total variance explained table. This table explains the number of factors extracted and the total variance explained by the extract factors. If we look at the left hand side of the table, the 13th row indicates 100% cumulative percentage explained. This indicates that if we extract 14 factors, 100% variance in the data would be explained. However, if we extract only for factor 63.589% variance in the data set is explained. Therefore, extraction does lead loss of sensitivity in the data set. Therefore, it is very important for the researcher to know the reasons for conducting factor analysis. Step 9. The next output that we get in SPSS is a scree plot. In a scree plot, the number of factors to be extracted is indicated by the formation of an elbow. In order to see the formation of an elbow, two straight lines are drawn from the axis and the point at which they intersect is referred to as an elbow. In the current example, a very steep elbow is formed. Therefore, an ideal solution would be a two-factor one. However, the total variance explained table indicates that a factor solution will result in only 38% variance explained, and therefore it is better to go with a 4-factor solution than for 2-factor one. The last and the most important table in the output sheet is the rotated component matrix. This table indicates the number of factors being extracted and also which observed variables are loading on a particular factor. In the current example, the holiday experience, poor experience, accommodation facilities, food load on factor number 2, good beach cleanliness and light knife load on factor number 1, safety, adventure and information load on factor number 3, heritage and souvenir load on factor number 4. This table therefore indicates which observed variable correlate to formulate latent variables. This information in turn can be used to formulate or revise hypotheses and refine analysis as part of this nature of the variables. It is important to note here that naming the factors is the responsibility of the researcher. The factor analysis output sheet just indicates the items which load on a particular factor. How to use them is the discretion of the researcher. Now, let's summarize the whole module. Factor analysis is the class of procedures from the family of general linear modeling. Factor analysis is a technique which is used for dimension reduction and for understanding the nature of the data and the variables being studied. In factor analysis, each variable being started is expressed as linear combination of the underlying factors. Factor analysis in SPSS involves a 6-stage process. The process not only tests for the assumptions of factor analysis but also talks in terms of finding the most optimum solution by implementing the rotated axis solutions. Factor analysis as a technique is used for market segmentation purposes. It is important to note here that factor analysis is different from cluster analysis and is used for dimension reduction only. Thank you.